Actually, NASA is supposed to release a high-resolution image of this object when it came very close to Mars on October 3rd.
First and foremost, NASA has broken their silence. They will be releasing their images of 3I Atlas on Wednesday via a live stream. So here they have the live stream page up. It's starting in 40 hours as I record this right now. That is at 12 p.m. Pacific time on the 19th of November.
And based on what you were describing, this could soon be the biggest story in the world, literally the biggest story in the universe. And so
SETI's sudden post on X caught everyone off guard. They alerted followers that NASA will share new spacecraft and telescope images of 3I Atlas on November 19th, images gathered not from a single observatory, but from multiple spacecraft and high-powered telescopes across the solar system. NASA rarely organizes a standalone event for a comet, and SETI rarely highlights one unless the data is compelling. The timing alone sent a ripple through the astronomy community. Why now? And why this object? At the same moment, new images of 3I Atlas began circulating. Crisp, high-contrast frames showing a bright, structured coma and unusual color patterns. The comet appeared larger and more vivid than surrounding stars, its shape changing subtly from frame to frame. The tail geometry looked asymmetric, almost restless, as if something inside the coma were shifting or spiraling. Even before knowing who took the photos, the visuals suggested a body behaving differently from an ordinary comet. Then came the images showcased in Avi Loeb's recent photo-based Medium post, spectacular, razor-sharp captures of multi-directional jets and dramatic anti-tail and a long, tightly collimated plume extending into space. These pictures weren't theoretical diagrams or enhanced renderings, they were real observations revealing just how active and how strangely active this interstellar object truly is. Each frame exposed more structure than the last, making 3I Atlas look less like a diffuse ice ball and more like a machine of gas, dust, and physics operating at full intensity. The convergence of SETI's signal boost, NASA's impending announcement, and these increasingly strange visuals created the perfect storm. Something about 3I Atlas is demanding attention, visually, dynamically, and scientifically. And with each new image, the question grows louder. What exactly is happening out there? While agencies like NASA have remained silent about any unusual behavior from 3I Atlas, a different stream of information has been filling the gap. Observations from dedicated astronomers working outside institutional walls. Without formal statements from space agencies, it is these independent observers who have offered the most continuous, detailed look at the comet as it evolves night by night. Their images, shared openly and without delay, have revealed structures and changes that would otherwise remain hidden until NASA's official data release. And among these contributions, one set of images in particular ignited a new layer of intrigue, the suggestion that 3I Atlas might actually be rotating fast enough for its orientation to shift in minutes. The observer behind these images later explained exactly how they had been captured. Using a straightforward telescope and an RGB camera with no filters applied, he sought to record the comet as faithfully as possible. He removed even the standard IR UV filter to avoid suppressing subtle colors in the coma. Dozens of exposures were stacked to reduce noise, and sharpening was applied conservatively, just enough to reveal structure without creating illusions. Across these sequences, taken minutes apart, the comet did not appear static. Its outline shifted slightly, as though stretching or twisting. Dust plumes seemed to bend or flare in new directions. Brightness gradients slid across the coma in patterns too consistent to dismiss as random fluctuations. For him, the conclusion was direct. The comet was spinning, likely counterclockwise from his vantage point, and spinning fast.
The possibility that 3I Atlas is rotating on such short timescales carries profound implications. Most comet nuclei take many hours to complete a rotation, and even the unusually fast ones rarely reveal noticeable changes on the scale of a minute or two. If this object truly rotates that rapidly, it means its jets may be sweeping across space like rotating nozzles, sculpting the thin, tightly collimated tails seen in so many images. Rapid rotation could also create complex internal pressure, fluctuating outgassing rates, or even fragmentation risks. It would make the comet's visual unpredictability, its shifting colors, its restless tail, and its asymmetric jets, not signs of chaos, but the predictable outcome of an object spinning under intense solar heating. The observer acknowledged the limitations of his equipment and the risk of overinterpretation, yet the consistency across frames made his claim hard to ignore. But the independent observations did not stand alone. Around this time, Avi Loeb published a concise but visually powerful article that brought together some of the clearest and most detailed images of 3I Atlas available to the public. Rather than offering immediate theories or speculative commentary, Loeb chose to let the images dominate the narrative. And in those images, the comet appeared nothing like the diffused, soft-edged object many expected. Instead, it displayed a complex architecture of light and motion. Multiple jets launching from different regions, branching off in distinct directions, forming intersections and forks that hinted at underlying structure. The anti-tail, impossible to ignore, cut boldly through the frame pointing directly toward the sun, while the main tail extended outward in a remarkably tight column, far narrower and more coherent than typically seen in comets. These features were captured across exposures taken days apart, yet they showed a consistency that suggested the object was maintaining or rapidly re-establishing its dramatic geometry. What made Loeb's curated imagery even striking was the sense of intentionality the comet seemed to project. The jets were not chaotic bursts, they looked organized, as if emerging from discrete vents or surface regions rather than from a uniform outgassing front. Some jets appeared fan-like, others spear-like, and together they formed a web of bright filaments radiating through the coma. Even without analysis, the images conveyed a sense of intense internal activity, a system of forces pushing, accelerating, twisting, and counteracting each other around a rapidly evolving nucleus. Loeb's decision to highlight only the visuals, without locking them into a single interpretation, amplified the intrigue. It left readers with the unmistakable impression that 3I Atlas is not merely active, but structured, not merely bright, but performing, and that the comet's behavior may require a more refined scientific explanation than the typical models used to describe ordinary solar system comets. SETI's earlier spotlight on NASA's upcoming event now sits in stark contrast to the silence surrounding these independent findings. SETI didn't comment on rotation, jets, or anomalies. They rarely speculate publicly, but their decision to broadcast NASA's announcement to their own audience gave the moment a kind of scientific endorsement, framing 3I Atlas as an object worth paying close attention to. Interstellar visitors are incredibly rare, and every scrap of data they offer has scientific value, whether mundane or unexpected. By pointing the public toward NASA's forthcoming image release, SETI effectively underscored the importance of what might soon be revealed, even without addressing any of the unusual behaviors currently being observed from the ground.
That anticipation now funnels directly toward NASA's November 19th event, which grows more significant with every new amateur observation. NASA has confirmed that multiple missions have recorded the comet, meaning its behavior has been captured across different wavelengths, instruments, and vantage points. If the rotation is real, NASA's data may confirm it. If the jets are sweeping in arcs, spacecraft imaging may detect their motion or structure. If the strange anti-tail is shaped by rapid rotation, solar wind, or both, multi-mission geometry will clarify the physics behind it. For now, the only images the world has come from observers who happen to be watching at the right time, in the right direction. Soon, however, we will have a view from space, cleaner, deeper, and far less ambiguous. Speculation around the nature of 3I Atlas remains grounded in scientific possibilities. Rapid rotation could be caused by asymmetric venting, with jets acting like thrusters that accelerate the nucleus. The comet might also be tumbling, shifting its orientation irregularly as sunlight heats different regions. Interstellar objects may contain unusual mixtures of ices, dust, or high-strength material that alter the physics of their behavior in ways we do not yet fully understand. None of these explanations require anything extraordinary, only openness to the idea that 3I Atlas is not a typical solar system comet, and that its formation environment was shaped by different stars, different pressures, and different cosmic histories. Yet the visual evidence remains undeniably strange. Multiple jets firing in different directions, a dramatic anti-tail sculpted against solar pressure, a narrow plume extending it to space with surprising coherence, all of this paints a picture of an object caught in dynamic motion. It does not prove anything exotic, but it strongly suggests complexity that begs for better data. This is where NASA, SETI, and researchers like Avi Loeb form an unusual scientific triangle. NASA waits for the data to speak, Loeb highlights anomalies, urging the community not to overlook what seems unusual. SETI signals interest without speculation, pointing the public toward observation rather than interpretation. Together, they frame 3I Atlas not as an oddity, but as an opportunity. As the world waits for the November 19th reveal, the nightly observations continue. Each new image adds another thread to the evolving narrative, an interstellar comet that refuses to behave like a quiet visitor drifting harmlessly past the sun. Instead, it appears active, volatile, and possibly rotating at a pace that challenges expectations. Whether the rotation is real, whether the jets are synchronized, or whether the comet hides internal dynamics we have never seen before, all of this now rests on the threshold of new data. And when NASA's images finally arrive, they may confirm the independent observations, contradict them, or unveil entirely new features. Until then, the sky holds its silence, broken only by the cameras of those watching.